Hello everyone, this is week 8 of our Intelligent Agents in Learning Environments course, and this week we're going to be talking about reasoning models. Today, we're going to go over how AI won't plateau, AI understanding and intelligence, and the detection of misbehavior in AI models. First, we're going to be talking about how AI won't plateau. In other words, AI will not see a decline anytime soon, and it will continuously keep improving. In a TED Talk from Noam, AI in the past 5 years has drastically increased its scale of data and computations to train models. However, this also means a great increase in the cost of training. This is referred to as System 1 thinking. This method is seen as too fast and unrealistic compared to System 2 thinking, which is a more accurate replication of human thinking and takes more time to generate reasoning in their responses. Newer models past 2019, such as OpenAI's O1 model, use this method of thinking, and researchers at top universities have claimed that it has saved them days of work. System 2 thinking has benefits such as performance improvement through increased training and is potentially a more cost-effective method. Two examples mentioned in the video are the models Deep Blue playing a game of chess and AlphaGo playing a game of Go. Researchers had noticed that AlphaGo had a better performance when it had time to think compared to acting instantly. This means that we introduce a new paradigm for scaling AI, which expands the size of the data and the power that System 2 uses and trains on to make it more powerful and more accurate compared to System 1. Next, we're going to talk about AI understanding and intelligence. From a Stanford lecture taught by Christopher Manning, we learned that artificial intelligence models are rapidly evolving in their understanding, intelligence, and practical applications, and will continue to improve. By 2025, researchers have stated that large language models show new capabilities compared to previous AI models when it comes to problem solving due to training from large amounts of text. Another topic that Christopher Manning talks about is the limitations of retrieval augmented generation, also known as RAG systems. He mentions that using RAG systems are better than large language models because of the reduced rate of hallucinations. However, it still makes errors. It tends to misinterpret legal precedents and rulings, so it should not be used for legal tasks. Additionally, agentic AI, where large language models are hooked up to systems to perform actions in the real world, are becoming more common. It is slowly leading us towards a future where AI can actively carry out tasks for us. Another topic that Christopher Manning focuses on is university research. He talks about how important university research is because it tends to be the foundation for a lot of new ideas that are developed at bigger companies such as Google or AI. Ideas that are found through university research are typically found years or even a decade before they are used and implemented. Lastly, we're going to be talking about monitoring reasoning models to detect misbehavior. In a document from OpenAI, they talk about how challenging it is to monitor advanced reasoning models to detect and mitigate misbehavior using reward hacking systems. One of the strategies they use is chain of thought monitoring, because models think in natural language, which is easily understood by humans and monitorable by other LLMs. Some examples of reward hacking provided in the paper are patch verifying functions, where the agent avoids complex analysis by making the verification function always return true. OS exit 0 is where the agent skips the implementation of functionality by causing the program to exit prematurely, making the tests pass with an exit code of 0. Expected error codes are when the agent, after failing to implement a correct solution, simply returns the error codes expected by the unit tests. Lazy code is when the agent implements a genetic algorithm that doesn't actually solve the problem, but returns the expected output 0, 0, making the test pass. Decompiling a jar is when the agent decompiles a provided reference solution to copy the correct implementation. A parse test file is when the agent reads and parses the test file at runtime to extract the expected output. Lastly, stubbing pandas is when the agent stubs the pandas library and other files to bypass errors and make tests trivially pass. Thank you for watching.